All right, so we're going to solve this first one. It's just a regular old inequality. So we're going to bring the numbers from one side to the other and then get the x's alone. So we add 1 to both sides, subtract 4x from both sides. So we get 2x is greater than or equal to 4. I'm just going to rewrite it up here so you can see it. Divide both sides by 2, and x is greater than or equal to 2. Now, if the problem doesn't ask you for interval notation, this answer's fine. If it does ask for interval notation, you need to use your bracket and your parentheses or you won't get full credit. You'll only get 3 out of the 4 points. So number 2 is the same thing. We just have a 3-part inequality. So I'm going to subtract 4 from all 3 parts. Now I want to divide by -3. Now don't forget, when you're dividing by a negative, your signs flip. So it would end up with greater than signs. And your inequalities should always be least to greatest, so you would want to rewrite that. And then for full credit, if it was asking you for interval notation, you would need to put your numbers in your parentheses and your brackets. Now don't forget, the fraction answer is fine. That's your exact answer. You don't have to worry about messing up with your rounding or anything like that if you leave it as a fraction. If you do round, I would do to the hundredths place, but make sure you show that it would be a repeating decimal. So you could do 0.66 repeating, and then 38 divided by 3 is 12.66 repeating. So you'd want to make sure to show that's repeating, otherwise you're not going to get full credit. Number 3, so use transformations to graph the basic function and f of x. So here we have an x squared. So our basic function is going to be the squaring function, which looks like this. So there's our squaring function. Now we want to graph f of x. So we need to take each x value, multiply it by 3, y value times 3, and then move it up 3. So if we start with the vertex, 0 times 3 is 0, and then we slide it up 3. If we do this point, 1 times 3 is 3, slide it up 3 more, we get 6. Then if we do 4, 4 times 3 is 12, slide it up 3 more, it's 15. So we have a really steep U here. So that would be our f of x. Now we want the domain and range. So the arrows on the end tell us our domain is -infinity to infinity. And then the range, since it has a minimum, our lowest point is 3, and then it's going to go up from there. So it would be 3 to infinity. Slope formula is change in y over change in x. So we're subtracting our y coordinates and we're subtracting our x coordinates. So the y would be 5 minus -4, and the x would be -2 minus 3. Minus a negative is plus, so that would be 9. And then -2 minus -3 is -5. So you could write it like that. You could write it like this. If you had subtracted them in the other order, the top would be 9 over 5. What's important is that you have the slope and that you have a negative sign somewhere in front of it so that you understand the line's going to be going down. All right, suppose a new car rental company charges $249 for the first day and $24 for each day after that. So we want to figure out how much this costs. So our equation, s of x, we know we're paying $249 for day 1. And then we know we're paying 249 days for the part after, but we're not paying for the first day. So we'd have to subtract 1 from that number to get the correct answer. And we want to use the greatest integer function because half the day we still already paid for. So if we were going for 8.5 days, we're going to plug that in. So 249 and then 8.5 minus 1, because remember, day 1 we already paid the 249, which would be 7.5. And then the greatest integer less than 7.5 is 7. So we'd plug that in and we'd get $417. It says interval notation, so that's going to be the squiggle brackets to mean $417, but this would be fine. The test shouldn't say interval notation there. The biggest thing, and I got to double check if I did this on the other answer key, is that we're taking that 1 away because the first day was the 249. That's what's the most important. If you don't take that away, you'd only get 3 points. All right, skyscraper casts a shadow 204 feet long. So here's our skyscraper, here's our shadow. Then we have a tree that is 20 feet tall and casts a shadow that's 12 feet long. We want to find the skyscraper. So this is similar triangles. It was like the cone problems we did in the lesson for one of the sections. So we're just going to make a proportion. So for the tree, the shadow to the tree is 12 over 20. And the skyscraper would be 24 over x. So to solve a proportion, we multiply, cross multiply. So 204 times 20 is 4,080. 12 times x is 12x. And if we divide both sides by 12, we get x equals 340 feet. Don't forget, units are important. If you don't put the units, you're going to lose credit. And had we come up to a decimal, we will want to make sure to round. So that's that problem. Number 7. In a certain city, the cost of a taxi ride is $3.25 as soon as you get in and 90 cents per mile after that. Write an equation. So f of x, you're going to pay $3.25 when you walk in, and then you pay 90 cents per mile after that. So that equation's fine. You also could have put it in a different order. It doesn't matter if you put the x first or the whole number because the order of addition doesn't matter. You could have put the 0 before the 9. You could have put the 0 after the 9. All of that's fine as long as you have the x in the right place and the $3.25 alone. For number 8, it wants us to do the midpoint formula. So we're going to use the 2 points that it gives us. And our midpoint formula is finding the averages of each coordinate. So if we start with the x's, 0 plus 1,000 is 1,000. Divided by 2 is 500, which is good. We're looking for 500 products. And if we do the y, 0 plus 14,000 is 14,000. Divided by 2 is 7,000. So our total revenue is going to be $7,000. So that's number 8. Number 9, Franklin parts make pieces that cost 15 cents each, and the cost to run the machine is $2,387 per week. If they sell them for $245 each, how many pieces must they sell to break even? So it's a cost revenue problem. Well, it costs 15 cents per piece plus that $2,387. Revenue, how much they make, is $2.45 per piece. And our profit is revenue minus cost. Profit profit, there we go, is revenue minus cost. So we would do 245 minus the whole cost function. So if we distribute the negative and combine like terms, we get $2.30 minus 2,387. So now we have our function. Now we want to know when they're going to break even. So break even means we're going to plug 0 in for our profit. We want to know when they get to 0. So we're just going to add 2,387 to both sides. And then divide both sides by 2.3. And we get x equals 1,037.83. Well, you can't sell part of a piece, So in order to break even, they would have to sell 1,038 pieces. So don't forget, if you gave me that decimal answer, you'd only get 3 points because you can't sell part of a piece. Number 10. Formula to find Fahrenheit temperature is this. There should be a C here. Find the range when the temperature in Celsius is from 14 to 26. So we're just going to plug those two numbers in and see what we get. So F of 14 would be 9/5 times 14 plus 32. So 9/5 times 14 plus 32 gives us 57.2 degrees. And then we want to plug 26 in because that's going to be our upper end. So if we plug that in, we get 78.8 degrees. So that's going to be our range, 57.2 degrees Fahrenheit to 78.8 degrees Fahrenheit. And it's inclusive, so we would put brackets. Find the zeros. Remember, 0 is just another word for x-intercept, or when the function equals 0. So we're just trying to solve this equation for x. I'm going to multiply by the least common denominator to get rid of the fractions. So 10 times 0 is 0. 10 times 1/5. 10 times 1 is 10. Divided by 5 is 2. And 10 times 3 is 30. Divided by 10 is 3. So now I'm going to subtract 3 from both sides. Divide both sides by 2. And I get x equals -3 over 2. If you turned it into a decimal, it'd be -1.5. Either of those is fine. It doesn't matter. Number 12. Use translations to sketch the graph by hand. Give the domain and range. So here we don't have to sketch the original, but I'm going to just so you can see where it comes from. So it's the cubing function. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, -1 cubed is -1, -2 cubed is -8. So here is our basic function, x cubed. Now again, you don't have to draw that, but I'm doing it so you can see. Inside the parentheses means we're going right to. So I'm just going to take each of these points and move it to the right 2. And now I have the transformed function. Domain and range of this, well, there's arrows going up and down, so it's going to be -infinity to infinity for both of those. So that's number 12. 13. So now we're working on our compositions and our operations. So f times g means we're multiplying those two functions together. So I'm going to do f of x, which is 2x plus 3, times g of x, which is 3x minus 2. And I'm going to multiply these. So 2x times 3x is 6x squared. 2x times -2 is -4x. 3 times 3x is 9x. 3 times -2 is -6. And now I'm going to combine like terms. So I'd get 6x squared plus 5x minus 6. That trinomial is going to be our answer. All right, let's do f divided by g. So f of x, 4x squared minus 3x. G of x is x squared minus 2x plus 3. And that doesn't simplify easily, so we can leave it just like that. Now let's do minus. So f of x is 3x minus 2. We're going to subtract g of x. I put g of x in parentheses because we're subtracting the whole function. So we want to make sure we're distributing that negative sign and not just subtracting the first part on accident. So if I distribute that out, I get 3x minus 2 minus 3x minus 4. And if I combine like terms, 3x minus 3x is 0, and -2 minus 4 is -6. All right, now we're going to do a composition. Fog, remember that O is our composition. So it means we're going to take G and plug it in for X and F. So instead of x, I'm going to write 4x minus 2, and then I'm going to distribute. So 2 times 4x is 8x, 2 times negative 2 is 4, bring down the plus 3, and then I combine like terms and get 8x minus 1. So we're just doing those operations with our functions. Number 17, I don't know what I did. Okay. Number 17, they give us the graph of absolute value in blue, and they want us to write the formula for the red one. So we know it's absolute value. So it's going to have to look something like this. The vertex went to the left 3, so we're going to put plus 3 inside the parentheses. We went down 1, so I'm going to put minus 1 outside. And now I need to figure out the slope. So to get from point to point, I go down 3 over 4. So negative 3/4. That negative flipped it, so we know we're right. So this is our equation for the red line. 18. When they give us a number in the parentheses and tell us to solve, we're just plugging that in for x. So if I rewrote this, I would just put negative 3 everywhere we see x in the initial equation. Now I'm going to do my exponents first. So negative 3 squared is 9. Negative 3 times negative 3 is 9. Now I'm going to multiply. And then I'm going to combine like terms, or I'm just going to add everything. So we get 54, 56. So that would be our solution when x is negative 3. 19 is another function where we are writing an equation. It is also absolute value. So we know it's going to start like this. This point is 1 to the right. So we write minus 1. Because remember, the original one starts here. And it's down 4. So we subtract 4 out here. And if we were to find the slope, we'd be going up 2 over 1. So the slope is 2, making this the equation for the graph. Number 20 wants domain and range. So the domain, remember when you have, I don't know what I did there. When you have a graph that goes off the edge, assume there's arrows. Unless it's obvious that it's a point, assume there are arrows. So that tells us that our domain is negative infinity to infinity. The arrows point down, so it's going to go to negative infinity. And then our highest point goes to 4 on the y, so our range would end at 4. Now we're going to solve some absolute value functions. So the first thing we want to do is get this absolute value alone. So we're going to start by moving the 4 to the other side, and then dividing everything by 4 to get our absolute value alone. Now that we have just the absolute value on the left, we can solve for our positive and our negative solution. Because remember, when you get a negative inside, it becomes positive because of the absolute value. So we have to have a positive and a negative. Now we can solve those. So we get x equals 1 and x equals negative 5. So both of those solutions should work. If we wanted to check, we could plug them in. So 1 plus 2 is 3. Absolute value of that's 3. 4 times 3 is 12. Minus 4 is 8. That one works. Negative 5 plus 2 is negative 3. Absolute value is positive 3. 4 times 3 is 12. Minus 4 is 8. So that also works. So our answers would be 1 and negative 5. If you put that in interval notation, you would have your squiggly brackets showing that it's the individuals, not the ranges. Okay, 22 is also an absolute value equation. So we solve it the same way. We have one where both sides stay the way they are. And then we solve it again where we make the right side negative. Just the same as if it's only one digit on the other side. We do the same thing with the expressions. So now we're going to solve. So I'm going to subtract 2 from both sides. 3x equals negative 1 minus 4. Add 4x to both sides. 7x equals -1. Divide both sides by 7. We get -1/7. So that's one of our solutions. For the negative side, we want to distribute that negative sign. Then subtract the 2. Bring our 4x over. So -x equals -3. And divide both sides by -1. So x equals 3. Those two answers should both work in the parentheses, or in the absolute value equation. Number 23 is asking us to graph this linear function and give the domain and range. So our y-intercept is -4, and then our slope is 1/5. So we go up 1 over 5, up 1 over 5. We can do the opposite in the other direction. Now we have our graph. So there's our function. Arrows on both ends, up and down, tell us our domain and our range are -infinity to infinity. Okay, number 24 says solve analytically. So that just means do the math out instead of graphing it. I want to get rid of the fractions, so I'm going to multiply by the common denominator, which in this case is 10, because 2 times 5 is 10. So if I multiply this, 10 times 3 is 30, divided by 2 is 15. And then 10 times 4 is 40, divided by 5 is 8. And 10 times 5 is 50. So now we've gotten rid of the fractions. So I'm going to bring the 8 over. Divide both sides by 15, and we get 58 over 15. That answer is perfectly fine because it's simplified. But if you decide to do the dividing out, don't forget to go to your hundredths place. And because it repeats, you want to show me that. So either of these answers are fine, but you need that repeat symbol to show me to get full credit. All right, and then number 25, the linear equation, y equals 81.76x plus 1022 provides an approximate value, and we're saying x equals 0. So we're doing, in the original equation, it's years since. We want to do the exact year number being entered. So if I said it was 2012, how would you figure out what number to plug in for y? Well, since the original year is 1998, we would subtract that and figure, oh, we need to plug in 14. So we're going to use that fact to make our equation. Instead of x, we're going to do x minus 1998. So if you take the year and subtract 1998, we'll end up in having the same exact equation as the original. So that's all you need to do. So that's the practice exam. Let me know if you have any questions before you take the test.